Hello friends, today we are going to see hybrid machining processes which comes under the category of manufacturing process. So in this we are going to see different hybrid machining processes and how they are useful in combination of other processes. So what is the importance of this hybrid machining process and how this hybrid machining process will help. Actually, the hybrid production or manufacturing means it is a combination of the process or the machines in order to produce parts in more efficient and productive way. That means if you see here the hybrid manufacturing is given as 1 plus 1 is equal to 3 effect. Meaning what? The positive effect of hybrid process is more than the double of the advantage of the single process. So if you combine the processes, that will give more positive effect as compared to one single process. So hybrid can have several meanings. That means combination of different active energy sources which act at the same time in the processing zone. For example, you can take laser assisted turning or the processes which combine the process steps that are usually performed in two or more process steps. So that is the meaning of hybrid. So in conclusion, we can say that the combination of the process gives the positive effect as compared to the single process. So if you want to classify the hybrid machining, it is classified as combined or the mixed type process in which all constituent processes are directly involved in the material removal. So this is what is the meaning of combined or mixed type process. That means all the processes, constituent processes are directly involved. And assisted type means what? That is only one part, that is one of the participating process removes the material while other only assist in removal by positive effect of conditioning of or conditions of machining. So if you see over here, the hybrid process is classified as one as a combination of different energy sources and another is the controlled application of process mechanism. So again that combination is classified as assisted process and mixed process. So if you see our example here, assisted process which are categorized as laser assisted turning or vibration assisted grinding, vibration assisted EDM process, media assisted cutting, laser assisted bending, and if you see the mixed process you can have EDM ECM combination or curved profile extrusion, and the controlled applications involve grind hardening, combination of removal and forming, and so on. So in this way these hybrid machining processes are classified. Now what is meant by assisted hybrid processes? First of all, we take the example over here as the vibration assisted hybrid machining process. If you see over here, vibration assisted grinding is a new technology because you know the conventional grinding process, and if you combine the grinding, conventional grinding and the vibration, you will get the assistance of the vibration for this conventional grinding, and that's why it is called as the vibration assisted hybrid machining process, which is most often ultrasonic range which is established that will help. So if you see over here the side grinding and the peripheral grinding, you can have that vibration curve. So you will have more you can say new technology as compared to the conventional grinding, which will help in this machining process. So vibration assisted EDM. Now what is this? Actually in micro EDM process, flushing conditions and the discharge gaps have been identified as the main influence. So if you improve the flushing strategy and optimize discharge gap control have led to great improvements. The relative movement between the tool and the workpiece causes the flow of dielectric and an agitation of debris particles in the dielectric medium. Due to this phenomenon, what happens? Settlement of debris on the bore ground and the agglomeration of the particles are reduced and the state of gap is equalized. So this is in case of micro EDM. So in this case, vibration assisted EDM, if you see over here in vibration assisted EDM, additional relative moment is applied in the system, that is two electrode workpiece and dielectric fluid, which will increase the flushing efficiency that results in higher material removal rate and better process stability. So if you see at the right side, you will see the three graphs in which one is there is no any vibration, second is the electrical vibration, and third is the fluid vibration. So again, this is a assistance of a vibration to the EDM process. Then ultrasonic assisted ECM. So electrochemical dissolution and the formation of passivating oxide layer occur on the workpiece surface by ion formation and the movement within the electrolyte producing a high intensity current flow. So this is what ECM process is: electrochemical dissolution and formation of passivating oxide layer on the workpiece by ion formation. This passivating layer is removed by ultrasonically accelerated abrasives that impact the workpiece surface. This process also helps to maintain a constant inter-electrode gap. So here if you see in the figure, there is a electrolyte and the abrasive. This is the workpiece, and here in general ECM you have electrochemical dissolution and formation of this passivating oxide layer. So this passivating oxide layer is removed ultrasonically by accelerated abrasives, which impacts on the workpiece. So it will help to maintain a constant inter-electrode gap. The second category consists of heat assisted. Heat assisted processes, that means the use of some external heat source which improves the machinability by minimizing the machining forces, improving the work surface and integrity, and so on. So laser assisted machining is one of the important and mostly used category of heat assisted. So laser assisted HMPs means laser assisted mechanical machining, laser assisted advanced machining. In laser assisted mechanical machining, laser is used to heat the workpiece and ahead of the cutting tool during conventional machining process such as turning, milling and grinding. So there is a assistance of a laser in this mechanical. So mechanical machining process involves turning, milling and grinding. If you combine this mechanical machining process with the help of the laser, so what will happen? The laser is used to hit the workpiece ahead of the cutting tool during conventional machining process. And laser assisted advanced machining, where laser assistance enhances the material removal in electrolytic dissolution and electrode discharge based AMPs. So these are the two types of laser assisted HMPs. So here you can say there is a combination of laser assistance, laser and mechanical machining that will help to improve the efficiency, or you can say improve the work surface integrity, and also which will enhance the tool life. So here you can see laser assisted turning. Here what is done? The main material removal mechanism is still one occurring in conventional cutting. So conventional cutting, as you know, the tool and the workpiece, and it will cut the work surface. But the laser action, what will do? It will soften the workpiece material. So machining of high alloy steels or some ceramics becomes easier. So in general, if you machine some ceramic with, so these are difficult to machine because they are some hard materials. If you can use the laser, that will soften the workpiece material, that will assist in easy removal of the workpiece material. So that is the one of the important use of laser assisted turning. So what is done over here? The laser beam is directly focused in front of the cutting tool, so resulting in easier machining and high process performance. So this can be used to machine so high alloy steels and some ceramics which are otherwise difficult to machine with the help of this mechanism. So that is one of the advantage. Then laser assisted ECM, also it is called as LAECM. The primary role of laser in this what? To improve the localization of dissolution process. So this is one of the important parameter, that is the primary role of this laser is to improve the localization. The main mechanism of material removal in LAECM is enhanced by electrolytic dissolution because of improved thermal activation by use of focused laser beam. So there is a laser beam is this is a workpiece over here, and in this workpiece, So this is a laser beam. So electrolytic inlet over here, and this is focused on the workpiece. So additionally, it helps to remove the passivating metallic oxide, as we see in the earlier slides, that removing the passivating metallic oxide laser formed on the workpiece due to evolution of what? Oxygen at the anode during electrolysis process. So with the help of the laser, it will be primer role of laser as to improve the localization of the dissolution process. Then laser assisted EDM. So what are the EDM drawbacks? Lengthy machining times and high tool wear. In general, EDM what? Machining times are more and the tool wear is very high. So laser drawbacks are formation of recast layers and heat affected heads and the low surface quality of the workpiece. So what is there? If you take only laser, you have the formation of recast layer and heat affected zones. And EDM drawbacks are lengthy machining times and high tool wear. So what is the solution for this? That is the combination. That is a hybridization of laser beam machining and EDM, as LAEDM addresses their respective disadvantages. So what are the disadvantages of the EDM and what are the disadvantages of the laser? They are solved by the hybridization of LBM and EDM. So what is that is called as LAEDM. So what it will do? It addresses the disadvantages which are caused due to EDM and the lasers. So LAEDM is generally used in the micro machining application for reducing production time and eliminating the recast layer and the heat affected zone caused by the laser ablation. So in general, if you are going to use this laser and EDM separately, so laser has its own drawbacks, that it forms the heat affected zones, and the EDM also have high tool wear and the lengthy machining time. But how to remove this? If you combine, now if you combine these two, that means hybrid, if you LBM, that is laser beam machining and electron discharge machining, if you combine, so what they will do? It will help to reduce the production time, and also what are the drawbacks caused by the laser, such as the heat affected zone and recast layer, they are eliminated. So this is one of the process you can use to combine or to remove the disadvantage of EDM and the lasers. So laser assisted EDM is LAEDM. What is done over here? A short pulsed laser beam, that is a short pulsed laser beam which produces high ablation rates, is used to roughly pre-machine the basic part picture, that is a groove. If you want to do something groove or hole or the cavity, so this can be done with the help of short pulsed laser beam capable of producing high ablation rates. So this is subsequently followed by micro EDM process within suitable dielectric to remove the surface defect caused by thermal effects of laser ablation and to finish the feature. So first of all, what I do, if you want to pre-machine some parts like groove, hole or cavity, they are subjected to short pulse laser beam, and after that, once this has been pre-machining is done, then it is post-machining is done by the EDM process with the help of some suitable dielectric. Why this is required? To remove certain surface defects which are caused by previously laser beam, or you can have the thermal effects of the laser. So finally you will get this combination of laser assisted EDM. A third category involves magnetic field assisted machining process. So magnetic field assisted HMPs rely on the enhancement of primary machining and finishing by addition of magnetic field with the aim to improve workpiece surface quality and material removal rate. So what is done over here? The primary machining or the finishing which is required, that is the assistance of the magnetic field. So magnetic field assisted EDM you can have, and the magnetic field assisted abrasive flow machining. So these are the two types with the help of which you can use the magnetic field assisted machining processes. So in magnetic field assisted EDM, debris accumulation in the machining zone that adversely affect the performance and the appearance has been perennial problem in the EDM. So what is the major problem in the EDM? That is the accumulation of the debris, and also which affects the performance and the efficiency. That is one of the major advantage of the EDM, that is the accumulation of the debris in the machining zone. So if you add the magnetic field, so which enhance the process stability and increase the efficiency of EDM by effectively removal of machining debris from the machining zone. So that, what is the meaning of this? If you employ the magnetic field, so whatever the problems which are causing uh, the problems caused by the EDM can be removed. That is, the debris accumulation is the major problem in the EDM. So if you effectively remove this debris, then that will be easy removal of the machining debris. That means you can have the proper, so you can overcome the disadvantage of this EDM process, that is with the help of magnetic field. So if you add the magnetic field, that will increase the efficiency of EDM by effectively removal of the debris from the machining zone. Here you can see over here, if you have the introduction of the magnetic field exerts a magnetic force. So here in this figure itself is a self-explanatory. So here you can apply the magnetic field, so which will create the magnetic force perpendicular to the electrode motion. Perpendicular to the electrode motion, and as the result of this, debris particles are subjected to magnetic force and the centrifugal force. So due to this, due to this magnetic field, what are the debris? These are the debris. So these debris have that subjected to the magnetic force and the centrifugal force. So the resultant force, which is the summation of this, as you all know, the resultant force is the summation of these two forces, and which ensures effective and rapid flushing of the debris particles. So if you remove this debris, that is, the flushing is the most important, otherwise it will create a problem, that is accumulation will hamper the process. So by creating the magnetic field, this magnetic field, what it does, it provides or both magnetic force and the centrifugal force, and due to the combination of these, the resultant force, these debris particles are easily flushed out and the process becomes easier. Then the second is the magnetic field assisted abrasive flow machining. So magnetic field abrasive flow machining, which is shortly termed as MAAFM, is an important hybrid AFM process where the assistance of magnetic field provides the means of controlling the cutting forces, and consequently the outcome of the process include higher surface finish and the finishing rate. This is the same process applicable, that is the creation of the magnetic field, and due to which some ferromagnetic abrasives are used over here. So magnetic abrasive brush is also there. So magnetic lines of the force, as you can see over here, the purpose is the same, and the process which will help to improve the surface finish and the finishing rate. So you can see over here the process is capable of producing surface roughness as small as 8 to 10 N. So external electric field assisted machining, so this includes laser percussion drilling for highly reflective metals. So this is one of the another process, or also you can say femtosecond laser micro machining of silicon with external electric field. These are again two important processes which we can see in detail in the next lecture. Prior to that, we will see combined hybrid machining. So combined or mixed hybrid are those processes in which two or more energy sources, tool or mechanisms are combined and have a synergetic effect on the material removal. They can further categorize as ECHMP, that means electrochemical hybrid machining process. As you know, the combined hybrid machining is nothing but the combination of HMPs. So what are the advantages they are providing? They improve the process performance, then production of largely stress-free surfaces, then good surface finish and integrity, higher productivity due to higher material removal rates. So these are advantages if you have combined hybrid machining process. So electrochemical hybrid machining process, what are the limitations? That is passivation of the workpiece surface by non-conducting metal layer, applicable to only electrically conducting material. This process is applicable for those materials which are electrically conductive. So corrosion of the machining elements and the surroundings due to use of electrolyte, chemical damage due to workpiece surface, the dependence of accuracy on the inter-electrode gap. So all these are the some limitations of ECHMP. So why there is a need of ECHMP? Conventional finishing process such as grinding, mechanical honing, buffing and super finishing are inexpensive and give good surface quality, but the use of abrasive imparts some inherent limitation. That means Due to the average, what will happen? Tool wear will be there, low productivity will be there, mechanical damage to finished surface. So what is the solution now? So combine ECM with some conventional machining. So conventional finishing process means what will happen? Due to that abrasive, you have a tool wear, low production and the surface damages. But what is the solution for this? So for this ECM, you combine with some conventional machining or finishing or AMP to develop an electrochemical HMP. So this is the solution for ECM. Now electrochemical grinding. So electrochemical grinding is nothing but the result of hybridizing ECM with the abrasive action of the conventional grinding. So as you clearly understand from this statement, that is hybridizing ECM with abrasive action of the conventional grinding means it will have abrasive particles. So the combination of ECM with the abrasive action of conventional grinding to machine the hard and the fragile electrically conducting materials economically, efficiently and productively without affecting the properties of the material. So ECG offers accurate and largely surface residual stress-free machining with no burrs and heat affected zone and therefore very little distortion. So electrochemical grinding, it is a very accurate and largely surface residual stress-free machining. That means there are no any burrs and heat affected zones. So very less distortion is there. So this is the equipment which is shown over here. So this is a grinding wheel over here and this is the workpiece and workpiece, then electrolytic tank, filter, heat exchanger, all the parts which are shown in front of you. So the non-conducting abrasive particles, first of all the non-conducting abrasive particles protrude just beyond the surface of the bonding material of the wheel, helping to maintain constant inter-electrode gap and acts as a spacer. Here it is, you can see over here, this area you can see over here. Bonding materials such as copper, brass, nickel or copper impregnated resin are commonly used for manufacture of metal bounded grinding wheels. So what are the functions of abrasive particles? To maintain the electrical insulation between anode and the cathode, continuously remove any passive layer, to determine the workpiece shape and the size. So here you can see this is the portion which is this is the portion. Now we can see this elaborated view here. There are three types of zone. If you find in the figure, you can see over the three zones. So what are the three distinct zones in this process? So zone 1, the material removal is purely due to electrochemical dissolution. So in this region there is a material removal due to the electrochemical dissolution. Now coming to this zone 2, the gas bubbles in the gas yield a higher MRR. You can see over here in this second zone, the gas bubbles in the gap yield higher material removal rate. So chemical or electrochemical reaction may result in the formation of passive layer on the workpiece surface. The abrasive particles not only remove the material from the work surface in the form of chips but also remove the non-reactive. This is what happening in this second zone. So what happens in the second zone? Chemical or electrochemical reactions, that is the formation of the passive layer, and the abrasive particles, they not only remove the material but also remove the non-reactive oxide layers. And coming to this zone 3, the material removal is done completely by electrochemical dissolution. So in this zone the material is completely removed by electrochemical dissolution, and these zones start at the point where the wheel lift just beyond the workpiece. That means this is how the wheel, this is the workpiece, and here this will take place when the wheel just, or the zone starts at the point where the wheel just lift beyond the workpiece. This zone contributes by removal of burrs that formed on the workpiece in the zone 2. What are the burrs which are formed in the zone 2 can be removed in the zone 3. So this is how this process takes place. So this is the elaborated view. This is the process. This is the you can see over here the flushing of the electrolyte and all this. This is elaborated here. So in this how the zone 1, 2, 3 takes place. Now EDM combined with the conventional machining. So you can see your electrical discharge grinding over here. So from figure, in the figure you can see over the workpiece, and there is the mechanical grinding wheel, and the servo mechanism attached and dielectric fluid. So an EDG, that is the thermally HMP, that electrically conductive grinding wheel is used as the tool electrode. So what is there? Electrically conductive grinding wheel. So this electrically conductive grinding wheel is used as a tool. Material removal occurs due to electrode discharge action. The abrasive component of the process ensures effective flushing, which results in improved material removal rate and enhanced surface finish as compared to conventional. As compared to conventional, it is a combination of electric, that is, you can have this mechanical grinding wheel and this will act as a tool, and the material removal occurs due to electrode discharge actions. So it is a combination of again the abrasives. Abrasive component ensures what is done, effective flushing, that is when these debris particles are effectively removed, the there will be obviously very good MRR, and also the surface finish of the workpiece is good, and that is what gives the added advantage. So which are some disadvantages of EDM, that is the accumulation of the debris and which hampers the workpiece surface. So if you combine this, then you will have that due to the abrasive components which effectively removes the what I can say, flushing will be done, and that's why MRR will increase and also the surface finishing will increase. So electric discharge diamond grinding, if you can see over here, you can see EDDG, metallic bond abrasive wheel over here is there. Now again here there will be a formation of the spark. So a metal bonded grinding wheel with embedded abrasive particle is used to enhance machining productivity and surface finish. So here there is a combination where you can use the metal bonded abrasive wheel and which enhance the productivity. Also here you can see here aluminum oxide, silicon carbide and CBN are commonly used as the abrasive process. So when the diamond is used as the abrasive, this process is known as the electric discharge diamond grinding. So these are the abrasive which you can commonly use in this process, and if you use the diamond, that's why it is called as a electric diamond grinding process. Then electrochemical discharge machining, ECDM. So ECDM is the combination of electric discharge machining and electrochemical machining. So it is the combination of what? EDM and ECM, which is used for the machining of electrically non-conductive materials such as insulating ceramics, glass and polymers. A complex combination of electrolytic dissolution and spark erosion. So if it is a similar process, this figure you can see here, you have seen that is in the EDM process. So tool, that is the electrode, there are the gas bubbles, electrolyte workpiece, there is a spark. So this is the spark you can see over here. So what is done over here, it is the combined with the ECM process. So the benefits of the ECM and EDM definitely will help to machine the materials which are electrically non-conductive. That is one of the major advantages. So electrically non-conductive materials you can machine with the help of this process, such as ceramic, glass and polymers. So this is the ECDM process you can see over here. It is a combination of ECM and EDM. So this you have seen over here how this electrochemical discharge grinding is done over here. Electrochemical discharge grinding, that is hybrid, that is the spark erosion, that last here you have seen over here. This is the same electro discharge diamond grinding, like this only you can have electric discharge grinding. So here again electrochemical discharge grinding hybridizes the spark erosion, electrolytic dissolution and mechanical abrasion to mechanically electrically conductive workpiece. So here the dissolution occurs at the workpiece due to electrochemical reaction. A passive wetting oxide layer is formed on the work surface during electrochemical reaction, and subsequent electrochemical phase the spark discharge and depassivate the oxide layer. So it definitely overcome the problems which are caused in the EDM process by the use of this ECDG process. So friends, today we have seen some hybrid processes. So in the coming lectures we are going to see some more processes. Till then, Take care of yourself. Thank you. Goodbye.